What is gravity? The invisible architect. We live our entire lives inside a force we cannot see, a force that never sleeps, one that acts on every atom in your body, on every grain of sand, on every drop of rain, and yet we hardly notice it. Gravity isn't loud. It doesn't flash or burn. It simply pulls, quietly, constantly. Sir Isaac Newton first gave gravity a name in the 1600s, when an apple fell from a tree. He realized something fundamental. The same force that pulled that apple down was also pulling the moon around the Earth. He called it a universal force zone that acts on everything, everywhere. His formula worked beautifully, but he didn't know how gravity worked. No one did. Then came Albert Einstein. Einstein changed everything. He told us that gravity isn't a force at all. It's a bend, a warp, a curve in the very fabric of space and time. Imagine placing a bowling ball on a trampoline. The surface dips. Now, roll a marble across it. It spirals toward the dip. That's gravity. Massive objects like planets and stars bend space-time, and smaller objects fall into that curve. But here's the kicker. We still don't know why mass bends space-time. We don't know why gravity exists at all. Unlike the other fundamental forces like electromagnetism or the strong nuclear force, gravity doesn't seem to follow the rules of quantum mechanics. It's the outsider, the mystery, and yet it governs everything. How gravity shapes the universe. Without gravity, there would be no stars, no galaxies, no planets, no light, no life. Billions of years ago, after the Big Bang, the universe was just a swirling soup of particles. Gravity pulled those particles together, slowly, patiently. It clumped matter into clouds, into stars, into solar systems. Without gravity's gentle hand, the universe would still be chaos. Gravity is the sculptor of the cosmos. It carves galaxies into spirals and holds solar systems in place like a cosmic dance. It forms black holes, regions of space so dense that gravity becomes infinite. It builds stars and destroys them. It decides how long a star will live and what it will leave behind. A white dwarf, a neutron star, or a black hole. Even your body was shaped by gravity. Your spine grew upright because of Earth's pull. Your bones are dense because they evolved to resist it. Remove gravity and your biology starts to fall apart. The strange relationship between gravity and time now. Prepare for a truth stranger than fiction. Gravity doesn't just pull on space, it pulls on time. The stronger the gravity, the slower time moves. This isn't a theory, it's been proven again and again. If you place two atomic clocks at sea level and one on a mountaintop, they'll tick at slightly different speeds. The clock closer to Earth's center, where gravity is stronger, ticks more slowly. This is called time dilation. It means astronauts aboard the International Space Station are aging slightly slower than we are. It means GPS satellites must constantly adjust for gravity's effect on time, otherwise their data would be off by kilometers every day. But think bigger. Near a black hole, where gravity is extreme, time nearly stops. If you hovered near the event horizon and look back at Earth, centuries might pass while you experience minutes. Gravity bends time itself like a slow-motion dial on the universe. What if gravity suddenly disappeared? Now comes the nightmare. What if, for some reason, gravity just shut off? The first thing you'd feel is nothing. Absolute nothing. Your body would instantly lose all sense of weight. You wouldn't fall, you'd float, but so would the air around you. Every object not bolted to the ground would begin to drift. Then it gets worse. Earth's atmosphere would start to escape into space. Oceans would rise, swirl into the sky, and scatter. The moon would leave orbit. Satellites would fly away. The Earth, no longer held by the sun's gravity, would launch into the void on a straight line doomed to freeze in eternal night. Inside your body, chaos would begin. Blood would rise into your head. Your muscles would atrophy within days. Your bones would weaken. Without gravity's constant resistance, your entire biology would break down. No fire would burn, no rivers would flow, no life would grow. And here's the most chilling part. No one would hear a sound. Sound needs air. Air needs gravity. Without gravity, the world would fall silent. Real places where gravity acts weirdly. Real places where gravity acts weirdly. You might think gravity is the same everywhere on Earth, but it's not. In fact, gravity changes depending on where you are. Mountains, oceans, underground rock densities, they all cause tiny variations in gravity. There's even a place in Canada, Hudson Bay, where gravity is mysteriously weaker. Scientists believe it's because of a massive ice sheet that once flattened the region, redistributing mass and leaving behind a gravity anomaly. And then there's Mount Chimborazo in Ecuador. Because the Earth bulges at the equator, this mountain's peak is actually the farthest point from Earth's center in gravity. They're slightly weaker than at sea level. Not enough to make you float, but enough to make your weight just a little lighter. Even more dramatic, astronauts in orbit live in microgravity. They're technically in constant free fall, but they're falling with the Earth's curve, creating the illusion of weightlessness. Their bones, muscles, and even eyesight deteriorate because gravity isn't around to keep them functioning normally. But these are minor anomalies compared to what happens in deep space. Near neutron stars or black holes, gravity is so extreme it can rip atoms apart. These places don't just distort your body, they distort reality. And the closer we get to understanding them, the more we realize gravity isn't a constant law. It's a living force, sometimes gentle, sometimes monstrous. Could we actually lose gravity, and how? Now let's ask the forbidden question. Could gravity just stop? Mainstream science says no. Gravity is a fundamental force of the universe. It's tied to mass and energy. As long as mass exists, gravity exists. But then comes quantum physics. See, at the smallest levels, particles, quarks, strings, gravity starts acting weird. It doesn't play nicely with the rest of physics. Unlike the other forces, gravity has no known carrier particle. For electricity, we have photons. For the strong force, we have gluons. But gravity, we have no graviton. And this is where things get disturbing. Some theories suggest gravity might be a side effect, a leftover illusion from higher dimensions. In a universe with more than 3 dimensions, gravity might be leaking from somewhere else. If true, then it's not permanent, it's borrowed. Others suggest that if certain values in physics, like the gravitational constant drift, even a fraction, gravity could weaken. And if dark energy continues accelerating the universe's expansion, gravity may one day be so diluted that galaxies lose grip and stars float away into black nothingness. There's even a hypothesis called the Big Rip where the universe's expansion becomes so violent that it tears galaxies, stars, planets, and even atoms apart. Gravity would be powerless. Everything would be shredded by the fabric of space itself. Can we survive such a future? No. Can we predict it? Maybe. Can we stop it? Not even close. Final warning. Why understanding gravity matters. Gravity isn't just a background character in the universe. It's the main actor. It's the director. It's the stage, the lighting, the script. Without it, the universe has no plot, no structure, no end. We are surrounded by mysteries, dark matter, black holes, cosmic expansion, and gravity is tied to all of them. Every time we point a telescope into space, we're seeing gravity's fingerprints. Every cosmic collision, every star birth, every galactic spiral, gravity is there. Yet, we still don't fully understand it. Why does it exist? Why is it so weak compared to other forces? Why hasn't it been unified with quantum theory? Why do black holes, which contain the strongest gravity in the universe, also hide the deepest secrets of time and space? We live on a planet spinning in darkness, held in place by a force we cannot see, a force that could disappear in a way we don't yet understand. And that's the terrifying truth. Because if gravity ever fails, nothing else will matter. Not your home, not your dreams, not even time itself. Just endless silence, and the stars falling apart. The human body without gravity. A biological breakdown. You might think the biggest threat from losing gravity is floating into space. But that's just the beginning. The real nightmare is what happens inside your own body when gravity disappears. And it starts within seconds. Your muscles are designed to resist gravity every moment you're alive. Your legs hold up your body. Your heart pumps blood against gravity. Your spine, bones, lungs, they all evolved with gravity as their partner. Without it, the systems that keep you alive begin to collapse. In microgravity, like in space, your muscles begin to waste away. They're not being used. They weaken, shrink, and lose function. Astronauts lose up to 20% of muscle mass in just a few weeks, even with exercise. Imagine that happening on Earth, with no warning and no training. Your bones become brittle. They stop rebuilding themselves, because without the stress of weight, your body thinks they're not needed. In space, astronauts lose 1–2% of bone density each month. That's like aging 10 years in a few weeks. Over time, your skeleton would become fragile like chalk. A fall wouldn't break you. Just moving could. Then there's your cardiovascular system. Blood is meant to be pulled down by gravity. But if gravity vanishes, blood rushes upward into your chest and head. Your face swells. You feel constant pressure. Your brain thinks your body is overloaded, so it tells your kidneys to flush out fluid. You become dehydrated. Your blood volume drops. Your heart shrinks. And your heart isn't made for floating. It weakens, slows, becomes inefficient. On Earth, you'd struggle to stand, to breathe, to stay conscious. You could pass out from just trying to walk across the room. Then your nervous system starts to panic. Your sense of balance located in your inner ear relies on gravity to orient itself. Without it, your brain gets confused. You feel dizzy, disoriented, nauseated. Your body no longer knows up from down or left from right. There's no ground, no pressure, no feedback. Even your eyesight suffers. In space, pressure builds behind the eyes, flattening them. Vision blurs. The optic nerve can swell. Some astronauts experience permanent vision changes. Without gravity, your eyes begin to fail. And here's the scariest part. Gravity helps your body clean itself. Your lymphatic system, responsible for flushing toxins and waste, relies on gentle pressure to move fluid. Without gravity, that drainage stops. Waste builds up. Toxins circulate. Cells become poisoned from within. You'd be alive, technically, but your body would be rotting on the inside. And it doesn't stop there. Your immune system weakens. Your DNA repair processes slow down. You become more vulnerable to infections, mutations, and diseases. Even your sleep becomes chaotic. Gravity helps regulate circadian rhythms. Without it, your body forgets when to rest. This isn't theory. This is what we see in astronauts, and they still have some gravity, plus medicine, exercise, and constant monitoring. Now imagine all of this happening to everyone, everywhere, at once, without warning. Children, elderly, pregnant women, entire hospitals, first responders, no one trained, no support systems in place, no technology to help. It would be the most devastating biological collapse in human history. And worst of all, we wouldn't die quickly. We would slowly unravel, our systems collapsing one by one, as we floated helplessly in a world where the ground no longer holds use and where gravity, the invisible lifeline of our biology, is gone forever.